So let us try to consider operation in this plane. So I have a plane. So on the abscissa, I have the per unit current ID bar, and on the ordinate, I have the per unit voltage VD. So the question is, can I have operation in all the four quadrants? So by all four quadrants, what I mean is, can I have VD positive as well as negative? Can I have ID positive as well as negative? So if you have noticed, we started the analysis assuming that ID, the actual ID, is positive. So ID bar is also positive. So we don't get operation in the second and third quadrant. So we have operation only in the first quadrant and the fourth quadrant. Of course, VD can become negative because negative VD corresponds to invert operation, positive VD corresponds to rectifier operation. So the first quadrant is nothing but rectifier operation, and the second quadrant corresponds to, the fourth quadrant corresponds to invert operation. So let us see whether we can try to get some characteristics in this plane ID versus VD. So for that, I need to give some numbers for these equations. So let me call this as equation number 1. The equation in per unit quantities. Similarly, this is 2, 3, 4, 5, 6. So I'll come to the case of u greater than or equal to 60 and less than 120 degrees later. So let me first take up this one. U greater than 0 and less than or equal to 60. For u greater than 0 and less than or equal to 60 degrees. Let me go back to these two equations 1 and 2. So I have equation 1 relating VD bar alpha and U, and equation 2 relating ID bar alpha and U. So using 1 and 2, so if I want a characteristic in the VD ID plane, I can get rid of, say, alpha or U. So it's, you see that it's easy to get rid of U by adding these two equations. So if I add these two equations, then I get an equation relating VD, ID and alpha. So what I am trying to say is, let me just take these two equations and rewriting these equations. VD bar is half cos alpha plus cos alpha plus ID bar is half cos alpha minus cos alpha plus. So if I add these two equations, then alpha is U is eliminated, and I get VD bar equal to cos alpha minus ID bar. So if I take the plane in which I have ID bar on the abscissa and VD bar on the ordinate, so if I keep alpha constant, then this equation VD bar equal to cos alpha minus ID bar is the equation of a straight line. So I get a straight line, and the straight line intersects the VD bar axis at cos alpha, and the slope of the straight line is -1. So if I keep alpha constant, what I get is constant alpha operation. So it's if I have constant alpha operation, then for a given alpha, then the equation, I'm referring to this equation. The equation is that of a straight line. So it's a straight line in the graph of ID versus VD. Instead of equations 1 and 2, suppose I take equations 3 and 4. Okay, so let me rewrite those equations. Equations 3 and 4. So I have VD equal to half into minus cos gamma minus cos gamma plus ID is equal to half cos gamma minus cos gamma plus. So as I did in the previous case, I can actually eliminate u using these two equations. So if I subtract the second equation from the first equation, then I get VD bar equal to minus cos gamma plus ID bar. So if I take this plane where I have ID bar here and VD bar here, so if I keep gamma constant, then this equation that I have got is the equation of a straight line. So I have an equation of a straight line. So the slope of this straight line is plus 1. So this slope is equal to 1. So what I am trying to do is draw the straight line which is represented by this equation VD equal to minus cos gamma plus ID. So when ID is 0, VD is equal to minus cos gamma. So this straight line intersects the VD axis at minus cos gamma. So what I get by keeping the gamma constant is constant gamma operation. So that means if I have a constant gamma, then the equation that I have is that of a straight line. So for a given value of gamma, this equation is, this equation is that of a straight line in the graph of ID versus V. So this was obtained by eliminating u from two equations. Now instead of eliminating u, so in the previous case also we eliminated u and got a relation between VD ID alpha. So here we have eliminated u and got a relationship between VD ID gamma. I can take equations 1 and 2 and eliminate alpha. So let us see how that can. So let me take the equations 1 and 2. VD is half cos alpha plus cos alpha plus, and I have ID equal to half cos alpha minus cos alpha plus. So I'll write this as half cos alpha as alpha plus u by 2 minus u by 2. Similarly, I will write the second term as cos alpha plus u by 2 plus u by 2. So this can be shown to be equal to cos alpha plus u by 2 into cos u by 2. So I do similarly some manipulations and get an equation relating ID, alpha and u. So I write again this as half cos alpha plus u by 2 minus u by 2. Then the second term is minus cos alpha plus u by 2 plus u by 2. So this can be shown to be equal to sin alpha plus u by 2 sin u by 2. What I do here in this equation is I take cos u by 2, which is on the right hand side, to the left hand side. So I write this as Vd by cos u by 2 is equal to cos alpha plus u by 2. Similarly, if I take this equation, I shift sin u by 2 to the left hand side. So I get Id by sin u by 2 equal to sin alpha plus u by 2. Now I take the square of this equation on both sides, and I take the square of this equation on both sides. So after squaring, add the left hand sides of the two equations and the right hand side of two equations. So if you take the square of cos alpha plus u by 2 and add it to the square of sin alpha plus u by 2, you get 1 on the right hand side. So on the left hand side, we get Vd square divided by cos u by 2 plus Id square divided by sin square u by 2. On the right hand side, you get 1. So if I look at this equation, I have ID, Vd and u in this equation. So if I keep u constant, then what I get is constant u operation. So if u is constant, then this equation is the equation of a curve. So what is this curve? So this curve is that of an ellipse. So for a given u, this equation is that of an ellipse. So in the graph of Vd, in the graph of ID versus Vd. So if I take a graph where I have ID here and VD here. Then, of course, if I draw the complete ellipse, it's here. It's like this. Of course, operation is not possible in the uh, second and third quadrant, so I'm just showing it in the second and third quadrant, but its operation is possible only in the first and fourth quadrants. So operation is possible here, but not here. So if I complete the ellipse, I get it in all the four quadrants. So here, this distance is cos u by 2. Similarly, if I take a line parallel to the VD axis, then the distance from the VD axis of this line is sin u by 2. So what we get is an ellipse if I have constant u operation. So point to notice, if I have constant alpha operation, then in the graph of ID versus VD, I get a straight line with slope minus 1. For constant gamma operation, I get a straight line with slope plus 1 in the graph of ID versus VD. And for constant u operation, I get an ellipse in the graph of ID versus VD. So these were obtained for u greater than 0 and less than or equal to 60 degrees. Suppose u is greater than or equal to 60 degrees and less than 120, then what happens? Let us see. So I can get constant alpha operation, constant gamma operation, and constant u operation even for this range of u. So how do I get constant alpha operation? So essentially, I am asking what will be the equation of the curve if alpha is kept constant in the graph of ID versus VD. So for that, I have to consider the equations corresponding to the appropriate range of u, that is greater than or equal to 60 degrees and less than 120. So let me call this as equation number 1 for this range of u. This is 2, 3, 4. So if I take equations 1 and 2, I can eliminate u and get an equation relating VD, ID, alpha. Then I can see what will be the curve that I get for a given value of alpha. So if I take 1 and 2, add them, then what do I get? So I'll straight away write the result. So take equations 1 and 2. If I add equations 1 and 2, then what do I get? Let me just do a few steps. So I have constant alpha operation is my intention. So VD is root 3 by 2 cos alpha minus 30 degrees plus cos alpha plus u plus 30 degrees. Then ID is 1 by 2 root 3 cos alpha minus 30 degrees minus cos alpha plus u plus 30 degrees. So if I add the two equations, of course I have to multiply one of the equations by an appropriate factor and then add so that u gets the answer. So if I take the left hand side of the first equation and add it to 3 times the left hand side of the second equation. So I get root 3 by 2 cos alpha minus 30 degrees. And if I multiply the second equation by 3 on the left hand side, I have to of course multiply the second equation on the right hand side also by 3. So the second terms on the right hand side get cancelled. So what remains is plus root 3 by 2 cos alpha minus 30. So the equation that I get is Vd equal to root 3 cos alpha minus 30 degree minus 3i. So for a given alpha, this is the equation of a straight line with slope minus 3 in the graph of ID versus V. So for a given alpha, this is the equation of a straight line in the graph of ID versus V. So similarly, we can get what is known as constant gamma operation. So if I want constant gamma operation, then I have to go back to the set of equations. So the equations corresponding to u greater than or equal to 60 degrees and less than 120 degrees. I have to take equations 3 and 4 and eliminate u from the right hand side of these two equations. So you can do some manipulations and try to show that we can get a relation between Vd, Id and gamma. So I'll write straight away the relation. I'll leave it to you to see how we can derive this. So the equation that we get is Vd bar is minus root 3 cos gamma minus 30 degrees plus 3i. So if I take a constant gamma, then this is the equation of again a straight line in the graph of ID versus V. So for a given value of gamma, this is the equation of a straight line in the graph of ID versus V. So as in the case of u greater than 0 and less than or equal to 60 degrees, here also we can get the constant u operation. So let us see how to get constant u operation. So if I want constant u operation, so let me go back to these equations. So I have to again consider equations 1 and 2 and eliminate alpha. So let me see how we can do that. So I have equations 1 and 2. Equation 1 is Vd equal to root 3 by 2 cos alpha minus 30 degrees plus cos alpha plus u plus 30 degrees. And the second equation is Id equal to 1 by 2 root 3 cos alpha minus 30 degrees minus cos alpha plus u plus 30 degrees. Now, I leave it to you to show that this is equal to root 3 cos alpha plus u by 2 into cos u by 2 plus 30 degrees. Similarly, this can be shown to be equal to 1 by root 3 sine alpha plus u by 2 into sine u by 2 plus 30 degrees. So if I want to eliminate alpha, then I will retain the factor involving alpha on the right hand side and push the other factor to the left hand side. And similarly, in the second equation also, I will retain sine alpha plus u by 2 on the right hand side and push the other factors onto the left hand side. So from this I get Vd bar divided by root 3 cos u by 2 plus 30 degrees. So this is equal to cos alpha plus u by 2. So in this equation also, I push the terms on the right hand side, I push the factors on the right hand side other than sine alpha plus u by 2 to the left hand side. So I get Id bar divided by 1 by root 3 sine u by 2 plus 30 degrees. So this is equal to sine alpha plus u by 2. So if you look at either this equation or this equation, on the left hand side I don't have alpha, and on the right hand side I have in the first equation cos alpha plus u by 2. In the second equation I have sine alpha plus u by 2. So if you square both sides of these two equations and add them, so the right hand side you get 1, and the left hand side you get an expression involving Vd, Id and u. So if I do that, I get Vd square divided by 3 cos squared u by 2 plus 30 degrees plus Id square divided by 1 by 3 sine square u by 2 plus 30 degrees equal to 1. So if u is constant, then this is the equation of an ellipse in the graph of Id versus u. So for a given u, this is the equation of an ellipse in the graph of Id versus Vd. So we can get the different characteristics such as constant alpha, constant gamma, constant u, either for the case of u greater than 0 and less than or equal to 60 degrees, or for the case of u greater than or equal to 60 degrees and less than 120 degrees. So I'll stop here and we'll look at the other aspects of the characteristics in this graph of Id versus Vd in the next class.